Global Explorers, this is your Captain Carl speaking. Welcome aboard for a journey around the world with Digital FAO and Agro-Informatics. Please fasten your seatbelts, power up your curiosity, and join us as we cruise through the digital skies towards the future of agriculture. We'll be reaching our final destination shortly.
Just a quick announcement before we take off. This session is being recorded so others can catch up at their convenience. For the comfort of all passengers, we kindly ask that you keep your microphone muted unless you're speaking. And if you have any questions during the flight, please feel free to drop them in the chat. Our crew will be happy to address them during our live Q&A. Thanks for joining us, and we hope you enjoy the session.
Welcome everyone and welcome aboard at our next stop in our virtual workshop series called Travel Around the World with Digital FAO and Agro-Informatics. My name is Jana and I'll be your moderator today as we begin this exciting journey exploring how digital tools are reshaping agriculture, research and education one university at a time. Today's session is brought to you in collaboration with the Asian Institute of Technology, and we're absolutely thrilled to have you here with us today. I would like everyone to imagine today's session as a flight. So professors and students from Asian Institute of Technology and our FAO experts are your captains. They will be navigating us through the world of digital agriculture and innovation. And the students from AIT, they will be the crew leading the way of academia and research. As you could see in the introduction video, before we get started, I would just like to repeat just quick housekeeping rules, just to ensure that everything keeps running smoothly. So this session is being recorded. You can then share the recording with your colleagues, with your friends, so they can catch up later. I would like everyone to keep their microphone muted unless they're speaking. If you have any questions during this session, feel free to either drop them in the chat or at the end of the session, we will have our Q&A. So you can raise your hand and we will give you the floor. If you're experiencing any technical issues, you can message me directly in the chat and we will try to fix it as soon as possible. I would like to highlight that this series is part of FAO's commitment to empowering youth, strengthening the bridge between education and digital tools, and mainly building global connections through innovation and collaborations. In every session, we'll hear directly from universities using tools such as the Agro-Informatics platform and digital services portfolio, or any other digital tools that are changing the way we understand, teach, and practice agriculture. So I would like to kick off this session. I'm very honored to welcome Captain Sumana to officially kick off today's session. And Captain Sumana, over to you. Thank you.
Thank you very much, Jana. Greetings to all of you joining us from all around the world. It is a privilege to represent the Asian Institute of Technology, AIT, at this international travel around the world with digital FAO and agro-informatics workshop series. At AIT, we are committed to advancing education and research that drive sustainable development across Asia and beyond. This initiative aligns closely with our core values of innovation, partnership, and global engagement. By bringing together diverse expertise, experiences, and perspectives, we recognize that the challenges in food and agriculture transcend borders, and so much are solutions. We are particularly inspired by the emphasis on empowering young people, building the capacity of future leaders in digital agriculture, artificial intelligence, and data analytics is vital to ensuring food systems that are not only productive and efficient, but also climate resilient, inclusive, and sustainable. As an international postgraduate institute of higher learning, AIT takes pride in nurturing innovators and problem solvers who are ready to address the pressing challenges of our region and the world. The digital AI-enabled resources provided through FAO serve as powerful tools that bridge the gap between research and practice. They help us translate knowledge into tangible impact, improving livelihoods, strengthening food security, and promoting sustainability across communities in Asia and beyond. This reflects AIT's enduring mission to foster technology and innovation that contribute to sustainable development and a better quality of life for all. This collaboration reaffirms our shared commitment to capacity building, global dialogue, and collective progress. Together, through digital innovation and shared knowledge, we can build food systems that are more equitable, resilient, and future ready. Thank you once again for joining us today. It is now my pleasure to hand over to our colleagues at FAO.
Thank you very much, Captain
Over to you,
Sumana.
Jana.
Thank you so much. I am now going to welcome my colleague Shubham. He's the captain for Agro-Informatics platform. So, Captain Shubham, over to you.
Hello, thank you for joining in. My name is Shubham. I am the developer for Agro-Informatics platform. Today in this presentation, I'll be covering Agro-Informatics, and I will give you a brief overview of what Agro-Informatics is, and then I will do a quick demonstration. So Agro-Informatics combine information technology with Earth observation and remote sensing for agricultural data management, analysis, and applications. It turns raw satellite images and field data into maps, indicators, and dashboards. Agro-Informatics is FAO's geospatial infrastructure that makes this possible. It's open source, web-based, and mobile-friendly digital public good. It brings together datasets from different domains and let us store, share, compare, and analyze all the data in one place with custom profiles for projects and countries. The platform itself is designed to support decision-making, planning, targeting interventions, monitoring, and evaluation. It's multi-sectoral, and interoperable. In the rest of my short talk, I will cover two use cases, two projects that Agro-Informatics is currently serving. It will give you a brief idea as to what it looks like in practice. So one example is Rift Valley fever. FAO has developed Rift Valley Early Warning Decision Support Tool, which is a web-based system, and it combines satellite-derived rainfall, vegetation data, climate forecasts, field surveillance data to estimate the risk of upcoming RVF outbreaks. It can flag potential hotspots 1 to 3 months in advance based on the specialized knowledge. On the platform itself, it appears as regularly updated risk maps, and a specialized audience such as veterinary services, health authorities can see where the risk is increasing by using data from different domains onto the Agro-Informatics platform. And this is what Agro-Informatics is in practice. It turns stream of different type of data, in the case of RVF, environmental and diseases data, into simple location-based information that helps protect animals, livelihoods, and people. Another example would be Agro-Informatics for Vapor, which is FAO's Water Productivity Open Access Portal. Water productivity.
Shubham, sorry, if I may, is there any presentation you would like to share with us?
I don't have a presentation. I'm just going to start a demo in 2
Okay,
seconds.
fantastic. Thank you very much.
Thank you. Vapor uses satellite data to monitor how much food we can grow for each unit of water and the amount of crop per liter that the water uses. That being said, we can see which districts are getting low yields and a lot of water. That being said, these are two portals that I wanted to talk about, but now I'm going to share my screen and give you a brief demo of how things look on the Agro-Informatics itself. On my screen, do you see the Agro-Informatics platform? Can
Yes,
somebody
we do. Thank you very much.
Thank you. On my screen, you see the Agro-Informatics platform. I would go over basic functionality first, and then I would start adding and fiddling around with data. On the top, you can see login, help section, which offers guides, language selection. We have all the UN languages, sharing and print functionality, which allows you to share the current view of the application with your colleagues, so you can work with collaboration. Map, which offers a 3D terrain and a 2D view with different base maps. You can have satellite typologies and different colors for the base map to see how the data would look onto the map itself. You have stories, which allows you to annotate your ideas while sharing it with the colleagues. It is a superset of share and print functionality, where share and print functionality allows you to just share your current view. Stories allows you to annotate the map itself with your own ideas. Analysis is basically analyzing the visual imagery that you see in terms of meaningful information like chart, tables, and other. In fact, in some cases, you can also generate imagery itself. Analysis is a very powerful tool for the Agro-Informatics platform. On this side of my screen, you see zoom buttons and location selection, so you can focus on your location. This is a split pane. It allows you to compare two different data sets onto the map itself, measure tool to see the distances on the map, and an annotation tool, which allows you to drop images or polygons onto the map for areas which you can use for further analysis. Here's a give feedback button. If you ever run into any issue with Agro-Informatics, you can use this or have any questions, comments, or concerns. Here is the workbench. The workbench contains explored data. Earlier in my presentation, I said Agro-Informatics houses data from different domains. Here are those domains. You can use the search bar to search different data set across FAO that Agro-Informatics has access to. And or you can simply go into these sectoral domains and add a data set. For now, I'm going to add a data set, and I'm going to talk about how it looks and works. On this side, you have Workbench, and you can see the data set itself. You can do an analysis by annotating the map. You can use any predefined boundaries, such as UN country boundaries of the world and different administrative boundaries. For now, I'm just going to do a polygon. Here's the analysis. Clicking the analysis button, it would give me the viable analysis for this data set. I can add it and do an analysis, which will then give me the profile of the polygon that I have generated. As you can see, it has a lot of wetland, a little bit of water bodies, tree cover, and for this much area. When you do an analysis, you will see the charting and the tabular view of the data that is generated. So Agro-Informatics offers 3 types of views. You can use this pane, the split functionality, which I said, to compare data sets, and you can add more data sets to the map. I'm going to, for this demonstration's purposes, I'm going to just add human population to quickly show how you can compare different data across Agro-Informatics. You can add the dataset to your workbench, and clicking the split pane allows you to add the dataset on the left or the right. I'm going to put human population on the right side. I'm going to put land cover on the left side. And now I will be able to see how human population changes with the type of land that it acquires. So for example, you can see in Tanzania, you have most of the human population centered around cropland. And then And this story goes on. You can add different type of data. You can add rainfall data, precipitation data to see how anomalies change for given amount of for different time frames. For example, this is 2020 human. You can change it to become 2019 throughout the Agro-Informatics platform. Now, I'm going to also demonstrate share and story, and then I will conclude my presentation and give the floor back to Captain Yana. So, as I said earlier in my presentation, that users can annotate their views and data. So I'm just going to quickly show how that is done. You can click on the story, which then opens the story editor, and you can see, I'm just going to say human population in Tanzania. And you can add different type of charts here, images here as well, and you can save it. Then I'm also going to say human population in Ethiopia. You can do this with any different type of data sets that are added to your workbench, annotate them. You can talk about all the data sets that are available here. Then clicking the sharing link generates this URL, which then you can share with other colleagues in your team to kind of bring together a conclusion. For example, for RVF, they use it between climatologists and veterinarian services to arrive at a conclusion that there is a risk of potential outbreak. As you see, I rated human population in Tanzania, then I went to Ethiopia, and it captures every step that you take on the Agro-Informatics platform, annotate with your ideas. Thank you for tuning in, and hope you enjoyed Agro-Informatics. I would now give floor back to Captain Yana. Thank you.
Thank you very much, Captain Shubham. This has been amazing live demo. I think everyone is very interested on how Agro-Informatics platform actually works. I have shared in the chat links for the Agro-Informatics website, as well as the platform, and I'm encouraging everyone to join our community of practice, where you can share your latest research information or ask any questions directly to FAO colleagues. Now we have second captain from FAO, Captain Missel. He will be presenting what is digital services portfolio, and then we will be focusing on the presentations from Asian Institute of Technology. So Captain Missel, over to you. Thank you very much.
Thank you so much, Yana. Can you see my screen and can you hear me well?
Yes, perfect. Thank you.
Fantastic. So let's talk about the digital services portfolio. So the digital services portfolio is a technical framework that allows implementation of mobile application to support and complement extension services. The main purpose of the digital services portfolio is to provide advisory messages to the last mile, farmers, livestock keepers, aquaculture farmers, and so on. The advisory messages are related to different domains, such as weather and crop calendar, livestock, post-harvest practices, insect recognition, and much more. FAO maintains the IT infrastructure while the content is created by national stakeholders. The project has originally started in Senegal and Rwanda in 2017, then implemented in Egypt, Jordan, Tanzania, and today we count about 13 countries onboarded. The tool is simple. It's composed by two main products, the mobile app for the farmers and an admin console for the national stakeholders to do the content management, but also to control their own entire instance of the DSP. This is one of the main features. This is the way we disseminate advisory messages. Every key message has to be simple, short, possibly actionable, and it's composed by a text, which is of course multilingual and the languages depends on the country, a provider to give credits to the authority responsible for that message, and can be complemented with medias such as images, video, externalities, or audio. And whenever the specific media is available, the related icon is displayed just next to the message. As you can see across the entire application, the way we disseminate advisory messages is the same. In the DSP, we group by the advisory messages by topics, and we call topics themes. Originally, the DSP has only 4 themes: weather and crop calendar, livestock, agri-market, and Nutri-Food. However, we implemented a feature called Theme Factory that allows national stakeholders to create custom themes based on the local needs. Here in the print screen, you see a sample from Tanzania related to aquaculture. The DSP is not only about content, but also data. And here's where the GPS location detected by the mobile app plays a key role. Through the location, we are able to consume services from Agro-Informatics platform or other FAO products, such as FAO crop calendar, FPMA for the prices, but also from external APIs like local services from the countries or other digital public goods. So the link between DSP and the Agro-Informatics platform presented by Captain Shuban is about the possibility of shaping the same data for a different audience and try to make it simply available for farmers. Now, in terms of recent development, what we are adding as a feature on the DSP involves AI. So here you see a print screen from the admin console where we try to benefit from artificial intelligence to create advisory messages which are simple and digestible by the farmers. It seems easy, but it is actually very difficult to translate technical agricultural content into something that is simple to be understood. On the left, you see another picture, which is small, but I'm going to give you an overview on one of the recent development related to DSP. So this is what we call DSP in a box. So for rural areas where there is no internet connectivity at all, what we did, we took a mini computer, a Raspberry Pi, we injected stated content with a USB, and the device itself behaves with an antenna like a local internet. So if there is no internet at all, this device allows to bring content on the field and behaves like a local internet. Now it's time for a very quick live demo. So let me switch to the actual mobile. So I mentioned that the mobile app uses the GPS location to detect your position. When you open the mobile app in a country that has no custom implementation, what you see is the default content, which comes with the 6 UN languages. And navigate through the DSP is just a matter of clicks. Main page is the list of all the domains of information contained by the application. And I'm going to showcase the weather and crop calendar. So these themes basically combines the weather forecast. In this case, the source is another digital public good, Met Norway, together with advisory messages. So in the advice tab, the goal is to provide on a regular basis updates like weekly or monthly meteo bulletins. And we have an integration with another FAO tool called Crop Calendar. So the Crop Calendar is another tool that provides periods for harvesting and sowing for a specific crop in a specific agroecological zone. And together with that calendar, the national stakeholders can provide advisory messages for the different process phase, fertilization, land preparation, and so on. There is a feedback button always available to allow the farmers to provide the feedback that can be anonymous, but of course we encourage to share an email or a contact to have a follow-up. Last but not least, related to AI, one of the latest implementation we did is the Farmer AI demo, which is integrated with another FAO new product called IDA. And here is going to load my last message, my last question to the tool. So this is an AI assistant that takes into account the location. In this case, I'm in Rome HQ, and then tries to respond with content related to that specific location. So in this case, I asked about aquaculture diseases. If the tool is not able to find any relevant information for my specific location, it's going to provide information from other countries. Here you see from Tanzania, some example of content. And that's pretty much it for a quick overview. Back to you, Jana. Thank you.
Thank you very much, Captain Misal. That was a great presentation on how digital services portfolio works and how powerful the tool is actually. So I think that we got a lot of interest from the participants. I've been also sharing the website in the chat box where you can also download the digital services portfolio. Once you open the website, on the right side panel, you have all the downloadable links. So now I would like to turn to our incredible students and professors from AIT. They will give us their insights and presentations on integrating remote sensing, geographic information systems, and information on advanced water resource monitoring and management. After this part of the session, we will have a Q&A session and open discussion. So if you have any questions for our FAO captains, for AIT students and professors, please prepare your questions or either write them in the chat or then you can raise your hand and we will give you the floor. We do have a guest speaker who will be providing a keynote remarks right after the presentation from AIT. So now I would love to give the floor to Captain Mohana. He's the assistant professor in water engineering and management program of the School of Engineering and Technology. So, Dr. Mohana, over to you.
Thank you, Jana. Let me share my screen. Okay. Yeah, those were very good presentations from FAO side. So now we are here. Would like to present from AIT side. Can you see the screen?
Yes, we can.
Okay. Yeah, I'm Mogna Sundaram, faculty in water program at Asian Institute of Technology. Today, I will be presenting on downscaling SMAP soil moisture data using a segmented CDF approach. The contents of the presentation is first I will talk about the introduction, then study area and research data that we used in this study, and methodology that we adopted in the study, and key results and concluding remarks. Yeah, I will keep the introduction very brief so that I will spend more time on the methodology that we adopted in the study. So as we know, soil moisture is one of the key variables, state variable that drives land atmospheric interactions, and also it plays a crucial role in agricultural processes as well. And it controls evapotranspiration, energy balance, and the development of droughts and floods. And it is also recognized as one of the essential climate variable by the WM. And the objective of this study is to develop and evaluate segmented CDF-based quantile matching algorithm to downscale SMAP data sets. So the main objective is how we can downscale the 9-kilometer SMAP soil moisture data to finer resolution, for example, say 1 kilometer resolution, so that it can be useful for some applications like agricultural water management, drought monitoring frameworks. So what are the key contributions from this study? So the key contributions are first, we introduced this improved segmented CDF algorithm for fine scale downscaling, which also bias corrects the soil moisture estimates from SMAP data sets. And second is derived soil moisture data from this approach can be readily integrated into irrigation management and drought monitoring. So coming to the study area is Nebraska, which is located in Great Plains region, North America. So it is in the Midwest of USA. And it has a steep elevation gradient, as you see here, elevation ranges from 250 meter in the east to 1,500 meter in the west. And this state is well known for intensive irrigation practices as they grow soybean and corn crops in this region. The climate is characterized by a continental climate with high interannual precipitation variability, and as elevation gradient, there is a steep gradient in the precipitation pattern as well. As you see here, in the eastern side of the state, receive relatively higher precipitation around 900 millimeter per year, while west receives less than 400 millimeter per year. And average volumetric soil water content is about 20%. And major soil types are sand and silt loam. And we selected this study because of a strong east-west climatic gradient. And also this state is well known for intensive agriculture and irrigation practices. And most importantly, they have a very intensive monitoring of soil moisture data using Nebraska Mesonet and soil climate analysis network centers using real-time soil moisture monitoring probes. So now coming to this research data, so we used three types of data in the study. So the first one is the SMAP soil moisture data, which is SMAP surface soil moisture data. SMAP level 4 data we used in the study, so which is available at 9 kilometer spatial resolution and 3 hourly data. So we aggregated to daily scales for our downscaling purpose. And this data is available from 2015 to 18. And the second set of data is in situ soil moisture observations. So Mesonet is monitoring soil moisture observations across Nebraska, 26 stations, and they monitor the soil moisture values at 5, 25, 50, and 100 centimeters below the surface. The temporal resolution is daily, and the data span for this data also we match with the SMAP soil moisture data, which is from 2015, April to October 2018. And we use this data for validation of the approach that we developed in the study. And the third type of data is precipitation data, CHIPS precipitation data. And it has 5 kilometer spatial resolution and daily temporal resolution. And this data, we did not use directly in the study, but we use this data to delineate climate zones based on long-term precipitation records, so that the climate zones were used in our approach for developing the zones-based CDF functions that can effectively downscale the coarse resolution SMAP soil moisture data to fine resolution soil moisture data at 1 kilometer scale. Okay, so now coming to the method, I just would like to explain a little bit detail of this method that we propose here in the study. So the SMAP L4 grids were first resampled to 1 kilometer grids. So first we resampled 9 kilometer to 1 kilometer by bilinear resampling method, and then we used the soil moisture stations map to extract the corresponding gridded values from this resampled SMAP data set. And once we have this time series data, we calculated mean monthly values. Let's say this is data set B. On the other hand, we have the observation, ground-based observation. So similarly, we calculated mean monthly values at all 26 locations, and we call this as data set A. And A by B gives the mean monthly correction factors at each stations, so which will be used to correct the resampled SMAP datasets later. Further, we also interpolated this point correction factor values to grid using IDW method, inverse distance weighting method, to generate the grids for each month. And then these monthly gridded maps for correction factor used for correcting the resampled SMAP grids. So this is called the mean adjusted SMAP grids. So until this process, it is nothing but linear scaling based bias correction. So that we usually do for any remote sensing data. If you want to correct the bias based on the ground station based or observation data, we adopt this linear scaling method. So once we get this mean adjusted SMAP grids, we overlay this climate zones, and then we filter the data based on the zone. So we identified 4 zones in state of Nebraska, and then the data were filtered first by zones, and then also it is filtered by the season month-wise. And we calculate the statistics like mean and standard deviation from the gridded data as well as from the observational data sets. So now we calculated Z difference, so which is the Z score based on the observation data and gridded data. So basically this Z difference describes how the gridded data are distributed with respect to the observation data. For example, this Z difference values will be negative to positive. Suppose if the values are more than +1, which indicates that there is overestimation of the gridded data with respect to the observational data. If it is -1 to +1, then both gridded data and observational data are fairly agreed on the same range. If it is less than -1, there is severe underestimation of the gridded data with respect to the observational data. So these are the 3 segments so that we identify based on this Z difference score, and then we fit the quantile matching functions to correct the gridded data with respect to the ground observations. So finally, we integrate those 3 segments to get the complete bias.
I think we lost a little bit of connection of Dr. Mohana.
Derived from this segmented CDF. So now we have to evaluate this method, right? So we adapted evaluation metrics, RMSE and MAE model performance indicators we use to evaluate this estimated soil moistures with respect to the ground observations. So we intensively evaluated this approach and data that we derived from this approach in 5 major steps. So first, we evaluated in temporal domain, where we identified 6 representative stations across Nebraska, and we compared with time series values and evaluated in terms of RMSE and MAE. Second, we also compared with the CDF profiles. We developed the CDF curves from the predicted soil moistures and observed soil moistures, and then we evaluated performance. And regional assessment, we also calculated the zone-wise average of soil moisture based on the ground-based observations, as well as the corresponding gridded data sets that we simulated from this approach. And for the spatial evaluation, we compared the ground-based soil moisture at 26 locations across the Nebraska at a particular time period on a specific day and specific week and monthly maps with respect to the corresponding grid-based soil moisture estimates. And finally, we also evaluated in terms of the anomaly with respect to mean and standard deviation values. What is the standardized soil moisture anomalies from the observations and the corresponding graded data sets. Okay, now coming to the results, just quickly, we will look at the results. The figure on my left shows the time series soil moisture for the year 2018. And you can see the black lines are the observations and blue lines are EA's map. That is the method that we adopt the study. And R's map is the resampled map. So it is just resampled with bilinear function from 9 kilometer to 1 kilometer. So this R's map we use as a baseline to compare our proposed method EA's map. And as we see here, there is a clear underestimation by R's map when compared to EA's map. EA's map well agreed with the observation data. And also here you can see this is the deviation error plot that shows how the error deviates from 0, 0 line, and these blue dots are from EA's map. So which means the errors are distributed close to the 0 values. The figure on the right is the cumulative probability functions for the 6 stations that we have shown here. So we calculated the cumulative probability functions for the observational data, R's map, and EA's map data. And as we see here, there is a close the gap between CDF functions of observation and EA's map is narrow compared to observation and the R's map. So now coming to this weekly averaged plots, we also evaluated on weekly data sets. So the daily data we aggregated to weekly scale, and then we plotted the time series at this 6 selected stations across Nebraska. And as we can see here, there is a close matching of the EA's map predicted soil moisture with respect to the observation. And also we found that the peaks and troughs of the predicted soil moisture from EA's map matches very well with observations. And the right side figure shows the CDF plots of the same data of 6 stations with respect to the observation, EA's map, and R's map. And we observe that there is a good matching between the observation and EA's map estimated soil moisture data sets. Then coming to the zonal average based analysis, we used
Rohana, just a kind sorry if I'm interrupting, just a kind reminder that we're slightly running out of time.
Sure, I will stand up. Okay, so here again we find a very good agreement between observations and the EA's map approach when compared to R's map approach. And coming to the spatial analysis, we just showed here the specific dates, simulated maps, spatial maps, and week and monthly aggregated maps. And we compared the 26 station values with respect to EA's map and R's map, and there is strong agreement with the EA's map approach. And it also captures the interfield level soil moisture variations when compared to R's map. And the final evaluation is soil moisture anomaly comparisons. So this map shows the soil moisture anomalies generated by R's map and EA's map, and there is a huge error or variability in terms of R's map with 8 to 22 standard deviation, while it is 1 to 3.5 standard deviation for EA's. So just to conclude the main results from the study, on daily scale, EA's map reduces the error more than 50% at most of the stations when compared to R's map, and soil moisture distribution CDF functions are very well aligned for EA's map. And temporal consistency, we found that there is a very good agreement on weekly and monthly scale that are when compared to the daily scale. So which means when we aggregate with coarser temporal scales, there is a good agreement. And then spatial prediction shows that ESMAP achieves the balanced spatial patterns, which with stable RMSE values throughout the growing season, irrespective of any specific wet or dry seasons. On anomaly detection, ESMAP reduces the anomalies greatly when compared to the RSMAP approach. And overall, ESMAP delivers a more accurate, stable, and spatially consistent representation of soil moisture than the RSMAP across CAP. And this SCDF approach effectively reduces systematic biases overall. So with that, I stop my presentation. Thank you very much.
Thank you very much, Dr. Mohana. I would now like to move to the second part of the presentations by AIT, which will be a video played focusing on IoT and water level monitoring. Dr. Sumana, I'm not sure who is going to be sharing that video, if Dr. Pianan or yourself. So over to you, colleagues in AIT. Thank you.
Dr. Mohana, please.
Jana, can we have this, playing this video after the presentation from Dr. Pianan?
Absolutely, absolutely. So I'm giving now the floor to Dr. Pianan. Thank you.
Yes.
Dr. Mohana, may I please ask for stop sharing your screen? Thank you.
Yes. Okay. Good afternoon, everyone. Can you see my screen? Okay. My name is Pianan Pipasiti from Asian Institute of Technology, AIT Thailand. I would like to share my research work in topic of assessment of potential report transpiration for sugarcane land suitability using GNS PWV with fuzzy AHP and multi-criteria evaluation approach. When we talk about the land suitability analysis, it's well known that the land suitability analysis is one of the important approach to determine the optimal area for future land uses. It has several criteria for analysis, such as climate, soil, hydrology or irrigation, and socioeconomic factors. However, climate change tends to intensify water shortage and droughts, significant impact on land suitability and crop yield loss, especially for sugarcane. Droughts can impact on sugarcane yield in Thailand, especially in the drought years by decreased yield ranging from 20 to 30%, as you can see in this graph. And moreover, sugarcane area were mostly cultivated in the northeastern Thailand, around 43% of the total sugarcane area in Thailand, which located in the rain-fed area as prone to droughts. So for this reason, we select these regions for the case study and indicate the drought condition to enhance the sugarcane land suitability map. And moreover, I consider the soil plant and meteorological parameter for this study. That I consider the potential evapotranspiration transpiration or PET. That's I select is because it's as a key parameter to reflect the water balance and link to droughts. And also I select the GNS PWV or GNS-based precipitable water vapor. It is an alternative technology as a ground observation to estimate the water vapor and develop the PET estimation model. because of it has a high temporal resolution in all weather, high detection accuracy, and the continuous data. And this study aimed to estimate the potential airport transpiration and the agricultural drought index for sugarcane land suitability analysis using GIS PWV and remote sensing data in northeastern Thailand. And here this is the overall methodology of this study. That we have three main parts. In the first part that I want to estimate the PET using by start from the analyze the precipitable water vapor or PWV using the GNS observation, and after that I use the meteorological data for analyze the daily site-based PET, and after that I use the MODIS land surface temperature to analyze the grid-based PET using the extrapolation technique for the objective to identify the agricultural drought index. In the same time, I also analyze the grid actual airport transpiration or AET using the Seaball model. And after that, I used bot data to analyze the airport transpiration deficit index or ETDI to as a drought index for the third pass to map the to enhance the sugarcane land suitability map. In the third part that I used 6 significant criteria such as the drought index, slope, soil texture, distance from river, distance from roads, distance from the sugar mill. That is this criteria is affected the sugarcane use. And after that, I use the fuzzy AHP technique to analyze the land suitability map and also analyze the potential area for sugarcane cultivation. And from this research, we can see that the variation of GNSPWV in terms of the seasonal and spatial variations. In the seasonal variation, that the PWV peak on the rainy season and low in the summer and winter season. And the spatial variation that you can see in this map, that is the PWV value has the high value in the upper part of the region. And after I analyze the PWV, we develop the daily potential airport transpiration estimation model using the daily mean PWV and temperature data, and it that show in this equation. That is after that I also test the validate the model. That's it. The result that show the strong correlation and good accuracy. And after that, I also test the performance of the site-based PET model using the existing model such as Green PET and ERA Finland against the FAO Penman Montage model. That's the developed model has a better performance than the other. That is this model can overcome the meteorological data constraint in some weather station using only the GNS PWV and temperature data. And after that, I also developed the model for the grid PET model, grid PET estimation model using the daily land surface temperature from MODIS image. That's shown in this equation. And it has a good accuracy and strong correlation. And after that, I also test the performance of the grid PET model that is by compared to the MODIS PET and ERA Finland against the FAO payment montage model also, and it has a better perform. The GPS model has a better performance than the others, and this model can overcome the shortcoming of the spatial resolution of ground meteorological station and spatial heterogeneity in the land surface. And here this is the spatial PET in the summer season during February to May 2020 to 2022, and using the GPS model and MODIS land surface temperature, and we can see we can find that the lower part of the region show the higher PET value than the upper part. And in the same time, in the spatial AET was analyzed in the same area and the periods of the PET data using the Landsat image. And we can find that the south and the southwest part of the region show higher AET values. And after that, we analyze the spatial AET map that show in this slide that we analyzed by the difference of the spatial PET and AET that we found that the south and the southwest part of the region show the area prone to droughts, and especially in Nakhon Ratchasima and Chayapum province. And moreover, based on the impact of drought and on sugarcane yield and cloud coverage in several images, the ETDI image in March to April 2020 was selected as the drought-prone area map for sugarcane land suitability analysis. And after that, we reclassify 6 criteria based on the guideline of FAO and the literature review as shown in this map, and use 6 map to analyze the land suitability and possibility for sugarcane cultivation in northeastern Thailand. That we can see that in this map, the green is the highly suitable class or S1. Green is the moderate suitable or S2 class, and yellow is the S3 class or marginally suitable, and N is gray is not suitable or in class. And we can find that the suitable class for sugarcane cultivation was mostly found in the S2 class, around 50%, whereas the area of S1 class were found only to 11%. And after that, I also analyzed the condition of each suitable class within the actual sugarcane growing area. That's all. We can see that the S2 class have the moderate and high links of drought and moderate and far from the river around 2 to 10 kilometers. And the S2 class whose potential to enhance to the S1 class by implementing the irrigation system and the irrigation establish the small ponds within the 2 kilometers and increasing the S1 class area by 2.7-fold. And however, the existing land used on the S1 class were mostly cultivated paddy rice, and the government should support the cooperative knowledge sharing program for sugarcane cultivation and focusing on the quota system, sugarcane price guarantee, and credit access. And conclusion of this study, GNS PWV and MODIS land surface temperature can integrate to develop the PET estimation model for assessing the daily size and grid PET, and it can overcome the limitation of spatial distribution of meteorological station and the influence of spatial heterogeneity in the land surface. And ETDI as a drought index is an important key for sugarcane suitability. And these studies suggest that the S2 class area cruise enhanced to S1 by allocate the water resources within the distance of the not more than 2 kilometers. And okay, this is all of my presentation. Thank you.
Thank you very much, Dr. Pianan. That was very interesting presentation. I think we got a lot of insights on your project. Now, as the last part for AIT part of the session, we will play the video. Dr. Sumana, or Dr. Mohana, I'm not sure who's going to share the video.
Yeah.
Then we will move to our guest speaker, and then we have the Q&A part. So please, if you have any questions for our presenters, speakers, if you would like to learn something more, if you need any more clarifications, either type the questions in the chat or prepare them, and I will give you the floor later when you raise your virtual hand. So now over to Dr. Mohana, I believe, to play the video. Thank you very much.
Yes, thank you, Jana. So I will play the video now.
Dr. Mohana, we cannot hear the sound.
Okay, I think the audio, you can't hear the audio clearly.
No, we cannot.
There is, no, I can hear the voice is slow, but I can hear the audio.
Unfortunately, we cannot hear the audio. Would you like to maybe try sharing in the advanced sharing options? If you click on that, you have share with the sound. If it's not possible, perhaps I could share this video with our participants because we are slightly over time right now. As an additional feature of the session, I'll be sharing the recording and the video that we could not play today, if that is fine with my AIT colleagues, and we can now move to the Q&A session.
Yeah, I think it's okay. We can skip this video.
Fantastic, thank you. Then you can share it with me, and I'm more than happy to share it with our participants. So one more time, thank you very much for your presentations, Dr. Mohana and Dr. Pianan. I think it was very inspiring, and it's very clear that the future of agriculture is in very capable hands. Really, I would like to thank you one more time for highlighting how collaborations and with universities and research organizations and academia are very important and crucial. Now we're moving to the next part and the last part of the session, which is Q&A. But before we start, we do have a special guest here today. I would love to introduce Sridhar Dharmapuri. He's a senior food safety and nutrition officer in the FAO regional office for Asia and Pacific in Bangkok. He's leading FAO's work in the region with strong emphasis on strengthening core elements of national food control systems that safeguard public health and enhance trade in food commodities through safe value chains. So, Sridhar, thank you so much for joining us today, and the floor is yours.
Thank you, Yana, and good day to everybody, wherever you are. So after such exciting presentations, I don't want to give you a long talk here, but because essentially we are all in it in a learning experience as part of this travel lab, if you can call it that. So it is my privilege to be here to represent FAO, to represent also be the as part of the regional office for Asia Pacific. We are based in Bangkok. We have close collaborations with the IIT in several areas. So we are very happy to see this grow further through this initiative, which has been led by Yana and many other colleagues from Rome in our FAO headquarters. So our focus in this region is very clear. We want to continue to work with countries on enhancing their agri-food systems from production right up to consumption and right up to the provision of safe and nutritious food and healthy diets for all. So the work that we see that we've heard today all from both from FAO and from AIT is vital not just for provision of these healthy diets, for production, for better economies, but also for markets, the well-being of many millions of people. So for me itself, I mean, I work in the areas of food safety and nutrition. So this is not supporting just a single action, but a whole ecosystem of actions. And that's the only way that change, transformative change, can be achieved. So we have seen in the Asian Pacific, this is a remarkably diverse region. We have very high income economies, as you know, as in Japan and Australia and New Zealand. We also have countries which are which are struggling in and are in a very advanced state, especially according to the IPC, the Integrated Phase Classification, where there's high levels of food insecurity. We also have countries, for example, in South Asia, which are very young, where the median age is actually less than 30, something like 28. We have aging countries in Southeast Asia. So Thailand is one of them, but then you also have countries like China and Korea and Japan. And we all need different levels of solutions. We need solutions for tackling youth unemployment. We need solutions for migration or reducing the migration from rural areas to urban areas. We also need solutions for the aged economy. So more technologies which will help us to keep up the pace of food production and food quality, food control, and ensuring their availability to everybody at affordable prices. So here in the office, here in the regional office, we are working closely with the governments, academic institutions like this one, like yours, and of course, young professionals. Youth and women are a big focus area of our work. So our approach is on collaboration, partnerships, convening, and influencing governments and people. And we want to continue to doing it with all of you and together, and by equipping ourselves with the best knowledge and technologies that this program has already brought forward. So we want to keep doing that. And I think this is an example of the progress we have made in our partnership, and not just in innovation, but in other areas. So we'll keep doing that. There will be other events happening very soon, starting early next year. And of course, we look forward to working with you and having you there as our partner. So thank you, everybody, for your great presentations. And I look forward to hearing more from all of you in the question and answer session. Over to you, Jan.
Thank you so much for that. I really appreciate your keynotes. I think that, again, highlighting the importance of partnerships and collaborations is really how we can make the change not only in region, but globally. And of course, the importance of youth and really working together on certain matters. It's the most crucial thing. So if you have any events or any upcoming activities that you would like to share, please either message me and then I can share with all the participants, so we ensure that external partners are involved as well. And one more time, thank you very much for joining us today. So now we are moving to the Q&A session. Now I would like to open the floor if any of our participants have questions for either the captains from FAO or the student crew, professor crew from the Asian Institute of Technology. Now is your time. So don't be shy. Please feel free to raise your virtual hand. I'm more than happy to give you the floor. We do have one question from Marilyn Valdivia for Dr. Pianan. It's in the chat, so Dr. Pianan, I will read the question. You can answer that. Any other questions? Again, can go into the chat or feel free to raise your hand. So, a question for you, Dr. Pianan. To measure the sustainability, do you also consider for future studies, including local perception of the people for land change and precipitation, to be integrated into the model? How it will be possible?
Okay, I think the actually in this land suitability analysis that I used the interview for sugarcane experts to weighting the criteria for the analysis, and the local perception that I think is a good idea for land stability analysis also, and precipitation I think is considered in the also consider in term of the potential evapotranspiration. I think it is include in the evapotranspiration also. Yes.
Thank you very much, Dr. Pianan. So participants, are there any questions? There can be also questions, of course, from colleagues from AIT for our FAO colleagues. So if, for example, Dr. Mahana, Dr. Sumana, if you have any questions more on how Agro-Informatics platform works or digital services portfolio, if you need any other clarifications, don't feel shy. You can ask anything you want. That goes also for Shubham and for Misal. If you have any questions for our AIT colleagues, please feel free. Any other additional information that, for example, Misal, Shubham, you would like to add to your presentations? Or if we don't have any questions, I think the presentations were that clear that there are no follow-up questions. In any case, if participants would like to contact FAO colleagues, I have shared the contact details in the chat. If there are no more questions, except this one, I think we can move to closing remarks. Okay, from Asim, a non-technical question for FAO. How does this series contribute to FAO's work on the ground in the long run? Misal, Shubham, would you like to? I can also add, maybe Misal, would you like to start answering this question? I can add also something. Thank you.
Thank you, Yana. So actually, this is to me an opportunity to get in touch and see what university is doing, what FAO is doing, try to find collaboration or future collaborations. So for instance, it would be nice to see the work presented by our friends from university, if it's somehow possible to use it as a REST API or something like that, to integrate and try to give a better service in the case of the DSP. The final target is a very challenging target, the last mile, but that's the idea, I think, of the spirit of these kind of sessions, and trying to put us together and then make something good for people. Over.
Thank you so much, Misal. Thank you, Asim, for this question. I would like to add a few things that by this series we're trying to strengthen the collaborations between FAO and academic institutions. The main focus is on how students and researchers are using the digital tools. For example, the FAO Agro-Informatics platform and the digital services portfolio, or any kind of focus on digital tools in agriculture, focusing on agriculture and food challenges. The whole idea is that every month we're traveling virtually to a different university, and just as like a summary, we're trying to build a global community or a forum, let's say, that is focusing on the youth who is committed to digital agriculture and so showcasing their work. Of course, this community is being expanded by each stop around the world and includes attendees from previous universities. So basically what is the impact or how does this contribute to FAO's work on the ground in long run? We can't really answer the question in terms of specific statistics or specific numbers, but we do hope that the tools that we're presenting and the students that are presenting their digital tools will have certain impact in regions and countries, especially, of course, with those ones attending these series. So that's just a quick summary from my side. Are there any more questions, or we can now move to the closing remarks? I can't see any hands up, so I would now like to move to the closing remarks. The first closing remarks will be done by Captain Shubham. So over to you, Captain Shubham.
Thank you. I would just like to say thank you very much for joining in and looking at the Agro-Informatics platform. Please feel free to try it. It gives you data from different domains. And if you ever run into any problem, you can reach out using the Give Feedback button, and we would be there helping you resolving your queries. Thank you.
Thank you very much, Shubham. Captain Wissel, over to you.
Thank you, Yana. Thank you, Shubham. So I presented the digital service portfolio, and I gave a very brief overview. So there is much more to say, much more to know about the tool. So the idea of this meeting is try to get awareness, collaborate all together. So what I want to say is that please feel free to reach out by email if you're interested to know more. So we can also get in depth for what the tool does and what are potential connection. So back to you, Yana. Thank you.
Thank you very much, Ms. Sal. And now closing remarks by Dr. Sumana from IIT.
I think Dr. Mohana, please go ahead.
Okay,
Yeah, thank you.
I will give
Dr.
closing
Mohana, I
remarks.
just want. Yeah, please. Please go ahead.
Thank you, and my warm appreciation to all of today's speakers, organizers, participants for making this session insightful, inspiring, and deeply engaging. Through our discussions on data-driven agriculture, digital innovation, and climate-resilient practices, we have seen how agro-informatics can transform information into impact, empowering farmers, researchers, and policymakers alike. These themes perfectly embody the vision of the Travel Around the World with Digital FAO and Agro-Informatics series, which celebrates global collaboration and the power of digital tools to make agriculture smarter, more inclusive, and more sustainable. A clear message from today's session is the importance of connecting science with practice. Data-driven management helps decision makers and farmers act with precision. On-farm experimentation ensures that innovation is grounded in local realities. Climate-smart research reminds us that technology must ultimately serve people and the planet. Together, these efforts demonstrate how digital transformation can bring tangible benefits across food systems when knowledge flows freely and partnerships extend across borders. At the Asian Institute of Technology, we are proud to contribute to this shared mission. As an international center of excellence, AIT is dedicated to developing the human capital and technological solutions needed to advance sustainable agriculture and food security in Asia and beyond. Today's dialogue reaffirmed that when youth are empowered with digital competencies and the spirit of innovation, they become true drivers of transformation in their communities. As we close, I encourage everyone to continue building on the connections and insight formed here today. Let us keep learning from one another, applying digital and data-driven approaches in the field, and strengthening the global network that this FAO initiative has spanned. Thank you once again for being part of this meaningful journey. Until we meet again, let us stay engaged, keep sharing knowledge, and continue leading toward more resilient, sustainable, and equitable food systems for all. Thank you.
Thank you very much, everyone. I'm wishing everyone a lovely day ahead, or lovely afternoon, lovely evening, and I'm looking forward to next sessions, which will recommence in 2026. So you will be informed our next stop, which will be with Brazil, University of Sao Paulo, preferably in February, but more detailed information will be shared with everyone beginning of next year. So thank you very much, and I will see you soon. Thank you. Goodbye.
Yeah, thank you very
Thank you.
much. Yeah, thank you,
Bye.
Thank you so
everyone.
much.
Yeah.
Thank you. Thank